Can everybody hear me? Yeah, I can hear myself now. Welcome to day 2 of Build. Welcome to Breakout 185, Cloud-Based Development Environments. My name is Jason Cook. I'm a global black belt with Microsoft. I specialize in everything developer tools and platforms. I'm part of what's called the Developer Audience Team. And I'm joined today by Craig Peters, Product Manager for the CodeSpaces product at GitHub. So again, welcome. So today we're going to talk through a couple different things. We're going to talk through what are cloud-based development environments and why do we care about them? Why do we need them? We'll do a little bit of demoing. We'll talk about features. We'll look at CodeSpaces and we'll look at Microsoft DevBox. Talk you a little bit through the differences between the two, why you would want to choose one versus the other, and you know which one is the right tool for the job. And then hopefully at the end we'll have enough time for some Q&A and we'll go from there. Cool.
Thanks, Jason. Good to see you all this morning. So why are we here? We're here because we want to keep developers productive and happy. And we've done a lot of research over the years in what does that. You know, between Microsoft and GitHub, we probably have a significant amount of the world's knowledge about how to make developers happy. This was some research that was done a few years back by GitHub called the Good Day Project. You can find the reference online there. But one of the things that we looked at is what gets developers out of the flow, what makes them unhappy. When do they have good days, when do they have bad days? Bad days are ones where they get a lot of interruptions, they have a lot of meetings, they make little progress towards their goals, and really only a tiny amount of their day is spent coding. Good days are days where they're coding. They're actually making progress toward their goals. We all know that even on a good day, software engineers don't spend all their day in their IDE. There's a lot of other things going on. And one of the things we're here to talk about is how cloud-based development environments play a role in making that as smooth as possible, improving the number of good days in the flow. So the things that interrupt flow are interruptions and distractions, like things that happen around you in your environment. Meetings are a good example of that. And there are all kinds of, this is just, of course, a subset. We all know that there's plenty more of that. But the idea is there's a class of things that are about your process and the way you work and the environment at which you work. And then there's also sort of technology and things like that. So, I work for GitHub. Merge conflicts are a real thing. Like CDs don't really help with that. Sorry. But below the line there, we spend a lot of time as engineers. Well, I'm a product manager. I talk to a lot of engineers. I'm no longer a real engineer. But a lot of the things they tell me about are that their environment's broken, that they have to update their dependencies to get the build to work or get the tests to run, that they spend time learning new code bases every time they're onboarding and setting up a new environment and getting that environment right. And that can take a long time. They spend a lot of time getting access to the right resources. They're waiting for IT. They're filing forms to get permissions to do something. All of those things are lost opportunities to take advantage of our creative minds, our collective ability to understand problems and actually make progress on the things we're trying to work through. So broken environments often come from things like dependencies, changes in the code base that we weren't aware of or weren't prepared for, things in the build environment that get updated without us noticing. Maybe we were on vacation. Even like hosts or services and all those things kind of change. And so that becomes a problem when everybody in your organization has to tackle that problem independently. You're doing that also in an environment where onboarding ends up being like a complex process. There are many steps to getting involved in a new company. You've got to get access to resources, you've got to install the operating system, make sure, as a developer, I don't know how many times you've gotten a laptop that had the wrong OS on it. I don't know about what's happened to me. The steps just go on forever. Like you got to get access to the right VPN, you got to get access to the runtime environment, and then you got to make sure everything actually works. All the pieces and parts work. The point isn't all of these steps. The point is that there are a lot of them, and we're not just doing those when we join a new company. We are doing this every time we're trying to collaborate with our colleagues. Every time we're trying to look at somebody else's code and understand how it works, because we're working together to make a larger system do something sophisticated. So this problem becomes multiplicative. Over and over again, we're onboarding to new projects, and each new project we're onboarding, we're having to scale this challenge of fixing the builds, fixing the dependencies, all of that. Well, the idea is that we've all faced this problem for so many years. The solutions that people have been trying, for the most part these days, have been virtual environments. So how do I create a desktop or a VM or something that I can automate all of the little nibs and knobs I need to get my job done into it? So how do I scale it? How do I actually address the security concerns? How do I optimize for cost savings? VDI is a great solution for a lot of things. If you're working as a knowledge worker and just need access to a machine to do something, VDI is great, right? For developers, we have special needs. We have special tools. We have access to other systems that we need to set up. We need build environments. Those things become huge frictions when you're starting to use VDI. You end up as a developer having to go that last mile to get you to a productive environment. Cloud-based development environments are here to bring you to that last mile, to get you to instant productivity without everybody solving the onboarding problem and solving the dependency and broken environment problem independently. Or even, we try to do things like write documentation. The problem with documentation is it's almost instantly out of date. It's always incomplete, right? So a cloud-based development environment is the idea of codifying this in a system so that each developer can always get access to an environment that's tuned exactly to the kind of work that they need to do. That will be self-service, that allows the right people to make sure that they're secure in exactly the right way. I don't need to worry about that as a developer. The security team has worked with the dev platform team to configure things so that things are automatically secure. And so that I don't have to be constrained by the fact I happen to have an 8-core machine, so I'm privileged, right? Like I've got a lot of cores. A lot of people don't have access to 8-core machines. Sometimes I need 32 cores, right? Like I need access to the right resources at the right time. Sometimes I need a GPU, but it's silly. It's ironic to be doing this talk with a M1 MacBook that I have over here because it also has a GPU, but I'm going to do part of the demo from an iPad where I don't, and or maybe it does. That's a good question. It does. And so it's ironic still, but it doesn't have 32 cores. So, and they're ephemeral. So the other thing about these environments is that you can run multiple of these things to have, because most of us are polyglots. We end up working in many different things at many different times, and maintaining all of those things in one environment is not, it's a pain at best. It's actually really rough. And then you're only paying for these things while you're using them for a specific thing. It's not a dedicated piece of hardware where 90% of the time it's totally underutilized. You're paying for what you're using. And so all of these things are attributes of cloud-based development environments. Another kind of dimension of cloud-based development environments are the things that, as a user, are built up to get us to being developer ready. There are kind of two foundational things. One is the configuration of the environment. What operating system, what packages, what tools, all of those things. There's the complementary thing as well. Which networks can it have access to? What are the audit controls? What monitoring things need to be on it? What policies need to be applied to make sure that it works well in my environment? So those two things together can get you to a working environment, but it's not yours. So it also needs to have personalization. How do we feel at home in the environment? Because that's been a classic problem of, like, say, VDI solutions, is that you get a generic VM. That doesn't always solve the problem or make me feel happy or in my flow as a developer. So we're here to talk today about two cloud-based development environment solutions under the Microsoft umbrella, CodeSpaces and DevBox. these sit in a place among a class of kinds of solutions from Microsoft. So we're differentiating them from Azure Virtual Desktops, which are great for non-developer kind of things, and Windows 365, which are really focused on the Office, Windows and Office 365 workflows. We're really more interested in the developer workloads. So like there's Dev and Test Labs, which do exactly those things. Those are great names. I love them. Naming is so hard. We were talking about that earlier. Dev and Test Labs is a fantastic name for things. But GitHub Codespaces and Microsoft DevBox are both services that we provide that we manage on behalf of our customers that are optimized for developers. Well, that can be pretty confusing. We have two. How do you choose between them? And that's what we're here to do today, is to help disambiguate these things so that you can choose the right tools for the right job. At a high level, the way to think about these things is that Microsoft DevBox gives you a full host. You have a VM that's optimized for cloud development in the cloud. Codespaces is contrasted with that in that it is a container that you are connecting to remotely from any number of clients that GitHub is running for you using GitHub management. So they come at this fundamental value proposition from two very different kind of perspectives. For both of them, they're on demand, right? One is allocating a VM, the other is allocating a container in which you do your development. For DevBox, you really think about it from the operating system up. It's Microsoft Windows today, and you as a team manage which images. Jason's going to go into that in his demo. You schedule the maintenance, you schedule the downtime. It gives you full access to an entire machine. You can connect to it via RDP, and it feels like a local thing. It gives you the ability to access local resources through Azure networking configurations, and the way RDP works, you can actually mount and access your local resources. And you can install desktop apps. You can run Visual Studio, right? You can build things that you can build in the kernel of Windows, whereas a containerized environment is constrained to the things that you can actually run in a container. GitHub is running a VM for you on the back end, but you don't have access to the operating system. We mount that, we run that container for you and give you access to that through either SSH or extensions and IDEs that know how to talk to remote connections. So VS Code, IntelliJ is in beta, and that family of products. And then what you're in control of is the container configuration, and we'll go into that in the demo. So CDEs in general give you access to these like on-demand, anywhere environments that are tailored to the task you're doing. And there are different approaches to doing that. So now we'll jump into some demos and deeper discussion.
Thank you. Yeah, so let's take a closer look at Microsoft DevBox. So Microsoft DevBox is ready to code, and what we mean when we say ready to code is that, as Craig had mentioned, they're built from the ground up from the operating system. So they include and encapsulate all the tools that you want to be able to use, whether it be Visual Studio, Visual Studio Code, IntelliJ, whatever that IDE is you're using, as well as whatever tool set you need to use. It doesn't need to be a specific set of tools. Whatever you can put on the machine, you can put on the DevBox. They're project-based, which means that we can spin up different pools of DevBoxes that are specific to the workloads that you're going to want to be working on. So if you're doing one project that's on .NET and you're doing another that's on Java, for example, you don't have to dirty that development environment. I know from my past, switching between versions of code and versions of libraries, that's a tough thing to do. And I was very hesitant, quite frankly, to do that kind of thing in the past because I was worried about blowing up an existing DevBox or an existing development machine. They're also managed and secured, which means that you can centralize the governance of them. You can centralize the security of them. We can look at that from three different perspectives. First of all, from the developer perspective, right? So as a developer, I have the workstation that I need based on the project that I'm working on. It's a self-service portal. I can go to that portal and I can choose, hey, I need my default box for development, or I need a specific box for a particular project that I'm working on. From a dev lead perspective, somebody who manages the team or manages the workload of the team, I can spin up pools of dev boxes that are specifically tailored to the particular project we're going to be working on. That includes things like the SKU or the cost controls, the tool sets. As I mentioned previously, I could have one version of Node or another version of Node on a different one. And then it also goes all the way down to the experience settings, the look and feel of the OS. And then from IT and from an infrastructure perspective, like I said, I can centralize all of the governance of those machines. I can set up network configuration. I can have workload-specific security controls, as well as enforce organizational policies for that matter. DevBox customizations is what gives you the ability to set up different machines for different workloads. Right now in preview, we have team customizations, which gives you the ability to create a set of DevBoxes in a pool that's specific to that team. What that means is that when you're building inside of the portal and you're building new dev machines inside of the Dev Center, you don't run the possibility of interfering with some of the other teams or creating new pools that might clobber an existing team for that matter. So it can be team specific. Once you have dev boxes built and the way you like them, customized the way you like them, you can image from them just like you would image a typical VM. You can snapshot it and then build additional dev boxes based off of that particular image. Individual customizations is just taking a dev box from the portal and being able to apply customization on top of it, which we'll get into that in a little bit. You can customize them through Dev Home as the new service that was released here at Build. And they're project-based catalogs, again, so I can delineate between the various things that I'm working on, and I don't have to worry about wondering or whether or not I have a specific workstation that's geared towards whatever the workload is that I'm going to be working on. They're managed in the same way that you would manage a typical physical desktop, right? They're managed via Microsoft Intune, which means you can apply conditional access policies to them. You can use advanced threat mitigation, as well as collect analytics and insights on things like device usage and health. You can set them up using Intune for automatic updates, as well as, I mentioned earlier, you can apply specific workload security to them. So if you have some workloads that are going to be significantly more security intensive, you can lock those machines down, whereas you might have other ones that you're not as worried about. So I'll show you a DevBox demonstration now.
Switch you over.
Thank you.
To 2.
And we're doing it live, if y'all remember that joke. 2. All right, so we're looking at the Dev portal. We're looking at the DevBox self-service portal right now. And because it's project-based, right now I have it defaulted to all of my projects. So I have 3 dev boxes. You can see here, default, dev beefy, and eShop custom. So if I wanted to narrow down to one particular project, let's start with one. These are my 2 kind of typical machines, right? The first one, default, that's just my normal working development machine, something that I might just hop onto to do my work. Something that I don't need very specific controls for, very specific workloads. On the other hand, the eShop custom one, this is one that I had set up, or I set up for myself here specifically to work on the eShop reference architecture. We can look at the customizations of this guy. We take a quick look here. And you can see that it doesn't necessarily say it right at face value. I could download the log of what it was specifically, but I know that what I did was I forcefully installed an older version of Node.js. And then in this particular case, I also cloned one of the versions of the eShop reference architecture so that I could work on it in the workspace on this machine as soon as I fired it up. My other project contains my Dev Beefy machine, which, as the name implies, is just kind of a souped up, bigger machine. If we look at the info on this guy, he's got 32 virtual CPU, 128 gig of RAM, 2024 solid state drive. So it's a pretty beefy machine. It's what I would kind of do my more compute intensive workloads on, if you will. Creating new dev boxes is a pretty simple process too. We'll take a look here. I just put in a simple name, test in this case, choose a project. I'll choose project 1. And then as I mentioned, I can apply specific customizations here. So what we're looking at is I started from the default image, which was just a basic Windows image with Visual Studio Code installed on it. And then on top of it, I want to apply customizations. I can do that either by pointing it at a repo that contains a YAML file that has the descriptor of all the various things I'm going to do to that, like install an old version of JS or clone a repo for that matter. Or I can supply it a file. I can say, hey, here's my customization file specifically. So maybe if I'm tinkering with it and I want to just spin up a new version of it, I can just supply it that file. Connecting to it is pretty simple too. We'll take a look at a couple different ways. First of all, I can connect from a traditional RDP connection. I have that done already, kind of like the baking show. I didn't want to spend too much time for that firing up. But we're looking at one of my working dev boxes here. This one in particular is my custom eShop machine. You can see I have Teams up and running, so I have the full Microsoft 365 set of applications running on there, so it's just like working from any dev machine. And then I'm also running Visual Studio here, and my battery is low. Running the eShop reference architecture. You can also connect via the browser, which in this case I think I've spun up my default here, which is the same kind of look and feel, same thing. In this case I have Visual Studio Code running, and then again I have Teams running. Pretty simple. And if we hop back here, I think we're back to Craig.
Awesome. Thanks, Jason. That was really cool. So now I think we should take a minute to take a look at sort of the other end of the spectrum. Let's take a look at the container-based environments that GitHub Codespaces provides you. So we'll jump right into a demo for that. So let me wake my machine up first. There we go. That's what I was looking for. So what we're looking at here is just VS Code. And I have installed the GitHub Codespaces extension. And what that does is that it adds this little tool where I can look at my existing Codespaces, or I can even create new Codespaces. It remembers which repos that I tend to work from. One of the things you'll notice about Codespaces is it's meant to be sort of on the fly based on the kind of task that you're doing. What do you want? So I'm going to go ahead and connect to one of these that I've already spun up, because I'm superstitious. And so let's just click that little button there. So what VS Code is doing is it's connecting to the Codespaces host using my identity as a GitHub user. And yeah, in fact, I have, in part of my preferences, is I actually like to have the VS Code panel on the right. And so that's one of the sort of flavors of personalization. It's a really basic one, I grant you, but you'll notice that when I go into the web UI, it also reflects that, right? Like those kinds of things follow me around. And one of the things I use a lot is the GitHub Actions workflow. I'm going to go ahead and authenticate with that. Why not? Yep, all good. And so this application is just the most trivial node application you can have. A really important attribute of Codespaces is that not only is it sort of like, this looks like VS Code, right? I can do things. It looks like a terminal. I can do the normal things you would do here. I'll say npm run. I never can remember for this app. I think I'm going to run start. Just do the basic server, exposes a port, and this port is then available from this remote host to me as a local server. So you can see it's proxying through my local loopback, whatever service it is I'm running on that. And so for any kind of cloud native application where you're using network protocols as your primary method of communication, so TypeScript applications, Go, Rust, whatever, Python, any Codespaces works really well for those kinds of applications. That's like a really trivial example, obviously. We'll get to that in a minute. But I have, I can have any number of Codespaces here. Another really important thing is that I can change the machine type, right? So I'm running here on a very simple machine, but I can choose any kind of machine that I would want in order to do this. Based on my policies for this particular application, I'm only able to get, actually it's for my demo enterprise, I'm only allowing up to the 16 cores. This enterprise doesn't have access to the 32 core machine. I could have added that, but no big deal. So that's kind of the basics. I work the way I normally work. I can get information about the machine that I'm connected to. I can see which repo it is. I can see my status from a Git perspective, and you just do the normal Git things you do. Codespaces on the back end is when you're running, obviously it's got a virtual machine that you're running the container in, all the work you're doing is saved to the disk for that virtual machine. And then when the virtual machine times out, you say you're inactive for a while, or I want to suspend my code space because I don't want to maybe pay for compute, I'm not going to use it for a while, and I don't want to wait whatever amount of time I have set up for my timeout. We store all of the work in progress on that disk and maintain that for the lifetime of the code space. So next time I come in, all my work is preserved, and I can proceed exactly from where I finished. So let's take a look at it from kind of another perspective. I want to understand like what kind of I want to share with you what kind of controls and things we have. So this is my demonstration organization, and the organization has, well, actually I should start from my individual. Sorry about that. Let's start here and show you what settings I have for code spaces. So as an individual, I have secrets that I can manage. I have my personalization. I can set up dot files so I can automatically load in all the aliases I want, whatever extensions I want to my shell. All of those kinds of things are available there. I sign all my commits with GPG, which is kind of a default thing in code spaces, so you can set that up. I have syncs, setting sync for VS Code so that my preferences travel with me wherever I am. And for setting sync and VS Code services, we do that in a secure way. So you have to trust certain repositories. Because there are side effects that can happen through those kinds of actions. And so we maintain a list of trusted ones. And then I can control which kind of editor I prefer to use and what kind of timeouts and which retention period, how long would I want to keep a code space that I haven't used for some period of time. We'll give you warnings and let you know when things are going to get deleted. And from my sort of code spaces management view, I can see which code spaces I'm running and who owns them right now. So that's another important attribute. We provide up to 60 hours of free usage of code spaces to every GitHub user as individuals. But they can, so for example, the things that are owned here by my Craig L. Peters demo account, that's the user account I'm using here, those are consuming that free usage, or I can pay for it, I can put a credit card in. These that are owned by the demo org is actually paying for the usage of that, and the demo org's policies are applying to that. So let's go look at those policies real quick. So this is the organization, Craig L. Peters demo org, and it has code spaces configurations. So the general configurations are things like, well, can users even use code spaces? So you can prevent users from using code spaces on private and internal repositories, which is really important for some of our customers' securities. They really don't want to allow that. If you use enterprise managed users, you can prevent those users from using code spaces at all. But if you use your users' public accounts, you can't prevent them from creating code spaces, say, on public repositories in other orgs. And in fact, that's exactly how a lot of people want it to work. So people can participate in open source communities and do side projects, and all the kinds of things that are important for us to learn. The next piece of that is who owns, who's responsible for paying, and whose policies apply to the code spaces that get created, and those are then controlled at the organizational level. And then the policies that apply, I have just two examples set up here. As a cost control, I wanted to restrict my users to a maximum of 100 minutes of idle time. They can set it up to some number of hours, and I didn't want to pay the extra amount that a user might opt to. And I also wanted to constrain the user's ability to forward ports to just the organizational level. So port forwarding can either be, so when I do forward a port, it authenticates the user who's connecting to that port. And I can be restricted either to just myself, only I can see my forwarded ports. So if I unclick this, it would be only the user who creates the code space can connect to that port. This allows any user who is also a member of the same GitHub organization, or this allows anonymous access to that. And so you have control as an organization about what kind of information and where that information can go from code spaces. And we have a set of policies that allow you to control security attributes and cost attributes of the product. And then lastly, I wanted to share with you kind of, these are sort of, I showed you kind of simple, trivial kind of examples. I wanted to kind of dig into a more complex one. There's another talk on this later here at the conference, but here I am actually looking at how GitHub builds GitHub on GitHub. So this is the dev container configuration for GitHub. And this is the default.com runtime. So one of the things that we looked at in DevBox is there's ways to have different configurations for different kinds of use cases. The way that's done in Codespaces is this is the default one for contributing to what we call internally and anecdotally the monolith, the .com monolith. It's like all the Ruby code that is all the controllers that control where you're going on github.com and your interactions there. But there's a lot of other pieces of GitHub. So for example, Classroom has its own dev container configuration. Actions has its own dev container configuration. All the different teams maintain their experiences within working in this environment. And so when they come into the environment, they'll have exactly the things they need. And these configurations can be quite, extensive and complex. Importantly, the dev container specification, we'll jump into that. Back to slides. Well, we hit on a couple of things. We hit on the fact that Codespaces is very tightly integrated with GitHub. So it's your identity, the policies and audit controls that come from GitHub. The dev container allows you to have multiple configurations within a single code base. Those live within a specific GitHub repo, but the configuration can reference any number of repositories that you need for a given environment and specify what should be the permissions for the token that is used to pull those repositories into the environment so that you can control who has write access and read access only to those. This configuration enables you to do fast startup. You can do things like pre-build these containers and store them in a container registry, or we even have a notion called Codespaces pre-builds, which will run all of the non-user specific actions all the way up to creating a user session. So cloning the GitHub repo, any updating packages, npm update, brew update, whatever you do in your environment to make sure it's up to ready to go. And then we snapshot that and then map that into an environment when a user requests it. So we have all of those kinds of tools, the creating and sharing of links, personalization, cost controls, and security. We kind of touched on all of those features. That's kind of the breadth of where Codespaces is. But an important attribute of that is this configuration as code. So the dev container configuration is an open specification that is collaborated on by many people in the community. It was originally a piece of the configuration for VS Code, and the GitHub team worked with the VS Code team to extract the VS Code specific attributes of it, because we recognized as a team that this could be a general purpose tool across communities to do that. And increasingly more and more tools, if you go to the containers.dev spec, you'll find there are a bunch of implementers of it, and more people are participating in this community because it provides declarative, portable, composable, and open environments that can be run anywhere. They can be run on DevBoxes. You can run Codespaces from DevBox. You can run it on your local machine. And this means that this repeatable environment isn't necessarily locked into any specific implementer. Oh, the thing I failed to point out about that, a couple of the environments is in the container world, what base container you use is a really important attribute. And so we're all concerned about supply chain security. The GitHub and Microsoft teams together maintain a set of base images that provide you kind of a good starter set. Most of our customers end up building their own base container images, and the dev container spec allows you to layer configuration on top of existing container images, but also if you have Dockerfile or Compose, it is an extension of your existing Docker image set. So now we've kind of looked at DevBox and we looked at CodeSpaces. There's a lot more to both of these products, obviously. Like this is just scratching the very surface, but we wanted to kind of sum it up and give you some tools to help figure out how to use the right tool for the right job. Today, DevBox is very Windows focused. You can obviously run WSL and do Linux things there. And that works great for a lot of people. But if you want like a Linux native environment that's containerized or you want to containerize your stuff and it's already containered, then CodeSpaces is a great option there for you. One of the things that's a fundamental theme of all of this is that the DevBox environment, once you're in the Windows environment, anything you can do in Windows essentially, you can do in a DevBox, right? Like it's wide open in terms of what source control management system you use, what tools you run on there, what kinds of workloads you're developing. All of those things, you get the power of a full desktop, right? In contrast, CodeSpaces is really focused on these task-specific tailored environments that are transient and come and go in short order. So I often talk to teams where developers have as many as 10 or 20 different CodeSpaces running at different times because they're balancing them all around. You might have 3 or 4 DevBoxes probably in a more typical environment. They end up kind of suiting themselves to different use cases in that sense. So the CodeSpaces support a limited set of IDEs, but anything you can SSH into works great. Cloud native apps and things like that. The next piece is that security and governance is fundamentally different between the two things. Microsoft has amazing tools for governance and security and audit and all of that. And so DevBox natively slides right into those scenarios. With GitHub, it's GitHub's management. So if you manage your things in teams and organizations, it'll be very natural for you. But if you don't, then that will be a little bit of a challenge. And then customization is done in today completely different ways. We're having conversations about finding some ways to share information about configuration between the two systems, but today they're entirely disparate methods of configuration and customization. So Jason's going to run us through some next steps.
Yeah, so obviously there's some clear use cases, right? Some of these are pretty clear, pretty simple, pretty well known, and then a few of these other ones in here are a little surprising, right? Obviously new employees. It's easy to onboard when you're using something like a DevBox or a CodeSpace, a cloud-based development environment. Same thing with new teams, right? When people move to a new team, when they move from one place to another and they need a completely new workstation to do completely new work. Consultants, third-party developers, partner teams, those kind of things. It's a great opportunity to use a cloud-based environment so that you can provide the hardware for them to work on without having to physically provide them a machine. That helps teams scale faster, obviously. IP protection and security. And because you're working on a cloud-based development environment, you can effectively reduce the blast radius when somebody gets onto a machine. Legacy apps. This is one of those ones that I thought was an interesting use case. You may work for an organization or you may work on a product that is fairly legacy and requires a legacy stack, something that maybe you don't have machines that support old versions or you don't want to have machines that are running old versions of things. You can spin up a cloud-based environment and put legacy stacks and legacy applications on it. Same thing with specialized hardware. You might run into an instance where you have a requirement for a highly specialized piece of compute, something really strong in terms of compute, or some very specialized software that you don't necessarily want to invest in terms of building out a new machine for the organization. You can quickly spin up a cloud-based machine that meets the needs, meets those compute needs, without having to go and purchase that hardware. Innovation, learning, experimentation. I like this one because this reminds me of culture of experimentation, right? The idea that me as a developer, when I'm working on something, I want to feel confident that I have the ability to experiment on the machine that I'm on without worrying about damaging an environment or blowing up production, if you will. Cloud-based development environments give you that ability to create the walled garden experience, the guardrailed environment where I can go forth and build and innovate, contribute to inner source and open source projects for that matter, without worrying about it. So the question, how do you get started? First and foremost, identify a champion, right? Somebody that can be an advocate, somebody that can learn within the organization, that can go forth and take the learnings and practices and take them to the wider organization and advocate for the use of development environments, cloud-based development environments. Start with a pilot team, and this is an interesting one. It's very analogous to the concept of doing Agile within software development, right? When we build software and when we transitioned to Agile, we got away from this mentality of building for 6 months and then shipping and waiting for another 6 months before we get feedback from the customers. In this case, we can do the same thing with cloud-based development environments. We can try a new tool, we can provision it on a machine and make that pool available to our developers. They can have it the day of us provisioning that, and then we can get immediate feedback from them on that. If they don't like the tool or they love the tool for that matter, we can get that feedback immediately and we can respond to it immediately. In terms of code spaces, it's super easy to get started. Go to github.com, pick a repository and spin up a code space. Take it for a spin, try it out. Pretty easy thing to do. Same thing with DevBox. When you need something that's a little more comprehensive machine, something with a full tool set on it, go to the Dev Center. Start with either a base image that is, has Visual Studio already on it, Visual Studio Code already on it, all the libraries you need. Or if you need customizations, you can start from a base Windows operating system and just build from there, install the things you want to install, create what we would consider to be a golden image and make an image of it, and from there you're running. So thank you.
Yep. Let's just highlight a couple of things about related activities that are here at Build. So actually yesterday there was a really nice developer experiences thing, but we can all watch that. There were a couple of sessions that happened yesterday. I hope you managed to get to them. I did want to highlight that later today there's an awesome session on using our tools kind of together, and highlights building web-based apps and games. And that's going to be an amazing session. And then on Thursday, there's the Azure Development Environments, which will really highlight the policy management around how you control deployments. And then we have some links for just how to get started with Codespaces and DevBox. And with that, we definitely want your ratings and feedback, but I think we have a few minutes for questions. Looks like we have 2.5 minutes for questions. Do we have any questions online? Nope? Okay, great. Well, we have time for the room. I see a hand back there. A mic is coming to you. Sorry, it's all the way over here. Or you can yell the question, I'll repeat it for the remote audience.
Sure. Can you contrast the code spaces with like Docker Dev containers?
Absolutely. So the question was contrasting code spaces with the Docker dev environments. So Docker dev environments today is a way to specify what goes into the container and some of the configuration of the tooling around it, which is an alternative to maybe 80% of the dev container spec. The difference today, I don't know what Docker is working on next, but the difference today is that they don't run a service that makes that a turnkey kind of part of the solution. It also doesn't have the sort of integration with GitHub auth and permission management and all the sort of policy controls around it that the service brings with it. Dev containers by themselves obviously don't do that on their own. So the differences are also that Docker hasn't yet got a big community around that configuration spec. We've been having some conversations with them. Up here in front, I'll repeat.
So you did mention that with DevBox we can work on legacy applications. Is that going to be constrained by Microsoft support policy, or by legacy? How legacy do you mean?
Well, just think of it as a...
Repeat the question.
Sorry, yeah. So how constrained would we be working on legacy applications, right, is the question in terms of spinning up the workstation. You're really only constrained by what you can install on a typical workstation. So if you're currently running a physical machine that's running Windows 11 or whatever version of Windows you're running, and you have a set of applications that you can run on it, you can install those same applications on the DevBox as well.
In terms of the operating system as well, or for example, like older .NET Framework versions that
If the operating system supports it, then yes, you can install the older .NET versions.
Can you talk about networking? Can you talk about networking and identity with Codespaces and with DevOps? DevBox. So, for example, can I add my current Entra ID on top of the Codespace or the DevBox, or can I assign a managed identity, and can I spin it up inside my VNet to use private endpoints for my cloud resources?
That is a fantastic question. So let's start with Codespaces, because the answer is that you don't currently, with Codespaces, have control over the operating system, which means that the host is not running the things that you need for Entra. And we're doing some experimentation with a couple of customers to identify what might be the best way to solve some of those problems. But today, the Codespace runs in a VNet. You have a dedicated VNet to each VM that is managed by GitHub and not on your network. So you need to find other solutions to do that, which include things like VPNs, is the typical solution, or Tailscale, or you can, as I showed, like with the VS Code client, you're tunneling to the local host. So you can use the GitHub CLI to create a SSH tunnel so that the local host can act as a proxy for that. But all of those are kind of like not natural acts. They take a little bit of extra things, and they're hard to do at scale. On the other hand, with DevBox,
From the DevBox perspective, couple different questions there. First of all, one, the IDP, the identity question. You can join your DevBox to your identity provider to Azure Active Directory, just like you would on a typical workstation, right? Me at Microsoft, I use my Microsoft identity to log into my DevBox, and it uses my Azure Active Directory or Entra identity. From the networking perspective, the physical machine, or the virtual machine, if you will, is hosted within Microsoft. But you have a network connection back to your VNet. So you spin up your dev center within your subscription, and then you have a network connection that acts as that proxy between your DevBox and your physical network or your virtual network.
And is there an option to give it a managed identity instead of the Entra ID? I want to do that.
You know, I'm not going to guess and say I don't believe there is, but that's something that, you know, I'd need to go to the documentation for.
Thank you.
thank you all very much for the great questions. This has been awesome. We are at time, and so thank you very much. And we'll both be at the conference the rest of the week. I'll be mostly around the GitHub booth and also at the Cloud Development Environment booth right next to it. Thank you all.
Thanks.